Okay, people, we are live now at 7 o'clock. So, welcome everybody to our meeting. Thank you. A few announcements to start. October 19th?
I think that's the date.
Is that the date for Joda?
That sounds correct. Yes.
October 19th for Jamboree on the Air to support the Scouts. We'll set up in West Park about where we did for the KI0E party. Notice will be going out to all of the Scout troops in the area that will be there. I can almost guarantee we'll have at least one Scout there. Hopefully we have more. You never know. We've tried this every year. I think we've had one year we had 2 Scouts show up. We did make contacts with other Scout troops, so it's good to support the youth no matter whether they come do it from our side or we're making contacts with them from somewhere else. So that'll be our Get on the Air activity for October. We're still working on our swap meet. It's very probably going to be the first Saturday in November. We just got to confirm that somebody will be there to open the building for us right now. And it'll be here in Meridian near the raceway, so easy to get to. Couple raffles going on back there. We've got the 50-50. It's actually 50, 25, 25. Currently, the 2 winners would get $7 each. If anybody else buys more raffle tickets, the winner will get even more. We have another bigger raffle coming up, and I will let Mr. Luke talk about that.
Okay, so one of the companies I get to work with is Steaming Coax. This is the latest and greatest in digital bird meters that have just come out. This is version 1. I'm going to loan this to you in the club. So on the 8th of this month, I get version 2, which is the version that's going to be released to the public. I'm going to do a YouTube video on it, do a full review. I cannot wait for you guys to see version 2. It's going to change how we meter and measure RF. This one unit can power up another 4 units tied together. So if you wanted to have multiple points in your station to measure from, I'll cover it all in the YouTube video, but the version 2 piece, I'm going to donate to the club. And are we going to do the raffle on the Christmas get together?
Yeah, we'll drop a ticket at the Christmas party in December.
So I'm going to throw this back at the table. He's going to bring it to all the other club functions so you guys can come up and touch it and play with it. But 100% of the ticket sales goes back to helping the club out for whatever we want to do. So.
And ticket sales for this are $5 a piece, so they're still not bad. And what did you say the retail cost was expected to be?
I don't think we settled on a price yet. It's going to be close to $250 to $300 for each unit. It's
So
a direct unit for a bird 43 meter.
and it's a nice unit. I've seen his review on this version without the updates coming on version 2. So I'm going to try and purchase a few of those raffle tickets.
You gonna do the tickets at $5 a piece?
Tickets are $5 a piece.
Make sure to write your name and your call sign clearly
Yes.
so we can read it, because it's going to be going over multiple different months, and if you're not present, you've got to be able to reach out.
And you'll still be able to win if you're not present, because that's why we need your information on it. Past events. We had our Parks on the Air out at Deer Flat, Lake Lowell, whatever you want to call it. Would you like to tell us how well it went for you, please? Because you single-handedly made more contacts than probably all of us out there put together.
Sure. That's all right. So my name's Jamie. It's nice to meet you all. This is my first time here. My call sign's Kilo India 7 Bravo Golf November. And I'm still a technician. And the only thing I can get on HF with is 6 meter and 10 meter. So I got an 891 and a Wolf River coil with just the whip and it resonant at 10 meters. So I took it out there with sitting on a Faraday cloth, and I got 90 contacts in a little over 2 hours. So all across the world.
We would all be jabbered away, and he's got his headphones on here just going contact after contact. So like,
you could see. You could see the smile on his face during that because 10 meters was open and it was doing great. I think everybody that was out there had a good time. We helped support the Middleton Harvest Festival / Emergency Preparedness Fair. Hoot was out there all day in Middleton handing out flyers on the club and for our next ham cram / testing session, which is coming up on the 26th in Middleton. And now the real work that went on that weekend, the rest of us who weren't playing in Middleton were out working on the container that's going to hold all of our repeaters on Squaw Butte. We stripped it down and painted it, took everything off the old building, so it's getting much closer to going up on the mountain. It looks very good. I'm not going to try pulling up a picture. Everybody who's been in our Facebook group, you can see some pictures that were posted of the container and the work party. Thank you, everybody that came. We're still working on design work on it, on how we're going to do all the electronics and stuff, but hopefully it'll be pretty bulletproof when it's up there.
Are you going to bolt this version to the ground so it doesn't blow up?
We bolted the last one to the ground, but the cables all broke.
The same
No.
day you stood it up.
The same day we stood it up. Yes, we set it up on the Saturday of the VHF contest this summer. There was a gentleman who was up on the top of Squaw Butte participating in the contest who told us how bad the wind was, like his hammock was laying sideways while he was in it. He was estimating 70 to 80 mile an hour winds down at ground level. The next day when somebody went up by our site, the building was laying on the ground. And the wind was shaking it hard enough, it broke 4 cables that were holding to anchors on the ground. It hit hard, and it amazes me because it broke the ones on the leeward side where the building fell over, not just the windward side. But we're getting there. Do I have any other announcements I got to talk about? October 26th in Middleton. Joda is October 16th, 19th at West Park. That was my first announcement.
We know how well Brian pays attention.
Yeah. And we're working on the swap meet for the first Saturday of November. Okay. Any other announcements? Can we give a standing ovation to Mr. Allen walking in the door? Thanks for coming, Alan. We like to have fun here. So, our presentation tonight is going to be half hands-on or 3/4 hands-on and partially up here with this. How many of you want to know how to analyze your antenna and tune it? Good, at least one. I didn't want to waste everybody's time. Go away. So, why do we want to test our antennas? How many of us have ever designed an antenna? Lots of us, right? You throw a wire up in the air, that's designing an antenna. You need to make sure that it's functional with your radio. You need to tune or adjust the antenna to make it resonant on the frequency that you want to use it on. You want to retune it. How many of you have had to retune an antenna? What happens anytime you move an antenna near metallic objects? It changes all of its settings, so you need to retune it. Who wants to make sure you protect your radio? It's important. How many people have ever designed a matching network? Of course, that one. A few. A matching network, you may have an antenna that actually has an impedance of, say, 300 ohms that you want to hook up to your radio. You need to match that 300 ohms to your radio. That's a matching network. When we use an antenna analyzer or a VNA, what are we usually testing for? The most common thing is SWR, standing wave ratio. It's normally called VSWR because it's voltage standing wave ratio, but everybody leaves off the V. How about return loss? What does that tell you? Come on. Return loss is how much of the signal that you send to the antenna does not come back to you. Basically, it tells you the same thing as the SWR. And there's formulas to convert between them. The impedance of the antenna. Why is that important? Because that's correct. We need to feed it. If we have an impedance mismatch, we've got some problems. And we adjust antennas for resonance. I'm going to say there's normally a common misconception in the hobby. Somebody will say, if my SWR is 1-to-1, that means my antenna is resonant. Don. Do we have a Don in here for food? Right here. He's busy looking at the toys. Resonance does not mean we've got a perfect match. That's one thing to remember. Resonance means that the capacitance and inductance in the antenna cancel each other out, so the antenna is purely resonant. It's purely resistive, which generally means it's going to be the best antenna. But it may not be resistive at 50 ohms, which is what our radios want. Why do we use 50 ohms? Basically because the government said so. They figured that was about the best. Cable TV systems use 75 ohms. Most video production uses 75 ohms.
What do you do if you got 75 ohms?
Use it.
What happens to your SWR?
You start out with about a 1.3 to 1 SWR, depending upon what antenna it's hooked up to. 1.3,
oh well.
Yeah. So with that, what do most people say is an okay SWR rating to use your radio on? True. Very true. And the higher the power output, the better it needs to be. Let's say 100 watts or less for us normal folks that run barefoot all the time. It's what? 1.5 or below, or 2 to 1 or below. Most books will say 2 to 1 and below is okay. I shoot for 1.5 to 1 or below. If you're trying to push, 100,000 watts, you might want to be a little less. But there's issues for that, and it's not necessarily because of the mismatch. It's where you're losing the power. Okay. This is always a confusing subject. What is voltage standing wave ratio, or SWR? Our signals are oscillating, right? They're RF. Here's our transmitter. The dark blue line, which may be hard to see, is the signal that's going out to our antenna. If our antenna does not have a perfect match to our feed line, some of that signal gets reflected back. The pink line in the middle is the reflected signal that's coming back. If you measure the voltage anywhere on that coax, depending upon what time, you could see the big peaks off of where both of those signals are added together. Okay. This little video, which I found, and I'm going to pause it here in just a minute and talk. Okay, if you've noticed, the top keeps changing, showing how that signal's going across with time. The bottom one is just taking the biggest part from the top and superimposing them on each other. So when we talk about that voltage standing wave ratio, it's the ratio between the low point and the high point. And for this one, 0.5 to 1.5 is about 3 to 1. And like it says, it's calculated out to 3 to 1. That's what we're measuring. It's how much of that signal is coming back, how strong it is, and how it relates to the signal that's going out. So VSWR has nothing to do with the power output. You could be running 1/4 of a watt or 5,000 watts, and it's not going to affect the SWR directly unless your coax heats up and causes problems. What? Okay. Why is SWR important? First thing is losses. How many of us have looked at a coax loss table and noticed as SWR goes up, the losses increase? Really important thing to pay attention to. And we'll talk a little bit about why. A high SWR creates larger losses in the coax. The reason it creates higher losses in the coax, all of the power that your radio is putting out, like if your radio is a 100-watt radio and you're measuring it, it's putting out exactly 100 watts. All of that 100 watts either is transmitted out of the antenna or turns into heat inside your coax. The signal will bounce back and forth between the antenna and your radio multiple times until the power is completely dissipated. So it still eventually ends up out at the antenna, but the more loss there is on each pass through the coax, the less power goes out and the hotter the coax gets. How many of you heard that you've got to keep the SWR low to protect the finals in your radio or your amplifier? That is an important thing as well. Okay. Something I found today in researching this, I've always heard that the reason they say it would damage the finals is because it dissipates the heat of that return in the finals. That's not quite true. What's really happening is it's acting kind of like power factor. Who doesn't know what power factor is? And I'm going to assume quite a few people. So power factor is AC. Normally, in an AC system, if you look at it on an oscilloscope, the voltage goes up and down. The current needs to follow the voltage exactly. That's a power factor of 1:1. That means at the highest voltage, the highest current's being taken. You multiply volts times current to get watts. In a system that has a less than 1 power factor, the peak on the current can either be before or after the peak on the voltage. So when you multiply it out, it may multiply out and be 100 watts, but in reality, you're only using 50 watts because of its voltage times amperage at a specific time. The power system sees that full 100 watts. Power companies hate things like inductive motors because it causes them to appear to be much bigger loads. In our radios, when that happens, our finals have to provide the power that's lost in that power factor. So if you've got a radio that's designed to do 100 watts, because of that mismatch, it may be trying to produce 150 watts. The current increases, and you burn up your finals. To me, that's interesting stuff, and I hope it's not too much for everybody. Okay, SWR. If you've got a high SWR, your system is not tuned to the transmitter. The mistuned system will cause extra power current in the amplifier, just like the power factor. Okay, losses. All coax has loss. In general, the larger the diameter of the coax, the less loss there is. There's a lot more to it, but in general, this coax will have less loss than the pieces on Hoot's mag mount car antenna. Coax losses are normally measured in dB per 100 foot at a set frequency. And we're going to ignore the frequency when we look at a little bit of calculations before we get into the fun stuff. The reason a high SWR causes us to put out less power, like we talked about before, our signal starts at the radio, goes across the coax, and we've got a loss. So like in the first column here, we're assuming that the coax has 0.38 dB of loss at whatever frequency. It's Belden 9913. So we lose 8 watts in our 100-foot of coax. Our antenna gets 91 watts, approximately. We have an SWR of 1.4 to 1, which means not all of that 91 watts gets transmitted out the antenna, turned into electromagnetic wave. Some of it's reflected back. So 89 watts goes out on the antenna, 2.6 watts comes back to your radio. We lose 0.2 watts of that traveling from the antenna back to the radio as heat in the coax, where it turns around and goes back again. So when we get back to the antenna the second time, we've got 2.3 watts of power. And if we do lots and lots of math, which we don't want to worry about, it says that we'll get 91 watts out of our antenna when it's all said and done. That exact same setup with an SWR of 3 to 1, we only get 86 watts out. 86 to 91, is that enough of a difference for us to worry about? What do you think, Luke?
On the receive side, if somebody trying to listen to your signal, no, it's not measurable.
Right.
If you're equipping it, it's going to be horrifically damaging.
You're going to heat
Over time,
over time, yes, right. But this is, I'm just talking about the loss in the coax.
does our hearing fall out of it?
No. This is a fairly low loss coax for that frequency. Okay, this chart is actually showing you the exact same information, except we're strictly at 1.4 to 1 SWR. This coax is our 9913, which has the 0.4 dB of loss. This is Belden 8216, which has 2.5 dB of loss per 100 feet. We're down to just barely half of the power going out. What would happen if we increase the SWR with that higher loss coax? The loss is going to increase even more. Because every time that the signal reflects back and forth, we have that loss. We want the least amount being reflected back and forth, so we only have one pass to lose on. Does everybody understand that at least enough to think about it a little bit? How many of you heard me always harp? Antenna and coax are the two most important things you can do on a radio station. That 5-watt Bofang right there with a good antenna and good coax will hit every repeater in this valley without any problems. With the right antenna, it could even hit more repeaters or simplex than Hoot's 50-watt radio because you can have the gain in the antenna. Okay, what else can we do with an antenna analyzer? You can measure the frequency response of a filter. Okay, tune filters, which we've got some up here for people to play with. Did you know you can measure the length of a piece of coax with a good antenna analyzer or VNA? What? Yep, time domain reflectometer. Okay, filters. What does a filter do? Why do we care about filters? Here is a passband filter. Why would we want to use one in the hobby? Most of the time, what you want, if there's other RF noise around you, you want a passband filter that will only allow the signal you're listening for to come to your radio. Because every other signal that comes in will desensitize your radio. It can cause interference. You can get harmonics, which will cause god-awful noise. You know, it's fun when Rod's pushing out 1,500 watts on 10 meters and I'm trying to listen to something. All I can hear is him, even when I'm on 2 meters. Okay. A notch filter. How many of you remember Radio Shack selling broadcast notch filters? They were a filter that would try to block out like the AM broadcast band or TV band. Or you could get one for a TV that blocks out the ham radio 6-meter band so you weren't messing with your neighbor's TV.
They were often advertised as RFI blockers for your stereo or your television.
Yep. How many of us will take a ferrite core and wrap it on a power cord of something like a pair of speakers? Why are we doing that? We're trying to filter out that noise. How do we measure length of coax? When it's rolled up, that's hard to do, or it's under the ground. This is, to me, this is fairly simple math, and it really isn't too complex. If you use a VNA, you send a signal down a piece of coax that's not hooked up to anything on the other end. Basically, all of that signal is reflected back. If you put a signal on it and measure how long it takes, you know how long it takes to travel from one end to the other and back. The velocity of light times the velocity factor of the coax times the time divided in 2. That tells you exactly how long the coax is. What, Mike?
That's assuming I know the velocity factor of light.
I put it right there. I'll print it out for you and laminate it. Using this math, something like a VNA or an antenna analyzer is really nice because you can measure it. Sometimes that we really need to measure the length of coax when you're making phasing harnesses for antennas or a harness for a multi-can filter. Or just calculating your loss. Say you buy this new house from a ham that's passed away and there's lots of coax in the ground. How long is the piece of coax? It's broken. Where is the break in the coax under the ground? You can use the time domain reflectometer to measure where that change is. Now you know where to dig to fix your coax. Okay. Most of my information up here is on different versions of the Nano VNA, because that's what I'm most familiar with, and it's an affordable device. There's lots of other antenna analyzers out there, but most of the rest of this is going to talk about the Nano VNA, and I want to give, especially the new hams, some ideas of which version to buy. The Nano VNA is an open source device. It was created by a guy who goes by the handle of EDY555. He's got a GitHub page that has all the information you need to build the device. He's created the firmware for it. A guy by the name of Hugen updated it, and you'll see a Nano VNA-H or a -H4. That's his design. The 4 means it's a 4-inch screen versus a 2.8-inch screen. Using these devices in the field for most of us in here who are over the age of like 30 and our eyesight's going down is really hard because the screens suck. They have about 40 dB of dynamic range, which means you can measure a filter that has up to about 40 dB of rejection in the filter. The 2.8-inch I looked earlier today, Amazon has what appears to be a decent version, is 60 bucks. They're cheap. Once you learn how to use them, you'll like them unless you're trying to use them outside in the sunlight. The H4, which has the 4-inch screen, is $85. I highly suggest for anybody, if you're looking at buying one, spend the $25 and get the 4-inch screen. It makes a big difference. There's another version out, the F. I've never personally used it. It's a couple of design modifications by somebody else. It works as well as the others. The original Nano works from 50 kilohertz to 300 megahertz. Any one that you buy today will work from 50 to 900 megahertz. It uses the third harmonic of the signal when you go up above 300 megahertz, which means your dynamic range drops. The same basic design, another group has created what's called the Nano VNA 2. That was the original marketing name. The 2+4, which is the one I use most of the time, has a 90 dB dynamic range. Every test that I've seen compares it to commercial equipment, says it's comparable. It's within 5 or 10% of your $10,000 VNAs. I've used mine to adjust small duplexers. Now the problem is you get a big duplexer that'll have more than 90 dB of rejection. You can't see it on your screen because you don't have enough dynamic range. The same group that designed the 2+4, which is what this one is, has one that they call the RFE VNA 600. It goes up to 6 gigahertz, and they have a B model which goes to 110 dB. So you can tune most duplexer cans with it. The B model is about 1200. The A model is like 600. So if you need to do high frequency, it works well. Most of us don't need to do that high frequency. If you're looking at a VNA, watch, especially a Nano, watch who you buy it from. Because they're open source, Alan here can change the design, skip a lot of stuff on it, have it manufactured, call it a Nano VNA and sell it, but it may have really cheap components or even missing some features. And Alan's going to get rich off of it. So with that said, be careful. If you buy one, get it from a source that you can definitely return it to. So if you test it and it's a bad design or a bad manufacturer, you can send it back. Okay, how do we use a VNA? VNAs need calibrated. When you're using one, you calibrate them. This actually has 3 little things in it. There's a 50 ohm load, so it can measure hopefully a perfect 50 ohms. There is an open, which is just a cap that goes on it that's kind of drilled out so there's nothing in the center conductor, and a short, which has a pin that's directly shorted to it, and you run through the 3 of those so it knows what it's seeing, so it's very accurate if you calibrate it. If you don't calibrate it, for most of our stuff, they're pretty good. But if you want to tune a filter, calibrate it first. The other thing that you need to do if you're going to tune a filter is you need to, I don't have one here. You need to do a through calibration, which means you connect the 2 ports together so it knows what's going on between the 2. Calibrate it for the frequency range you want to use. If you're going to work on John's 2 gigahertz Wi-Fi setup back there, calibrate it up there. Don't calibrate it at 30 megahertz, because the farther off in the frequency, the farther off your calibration is. These things are amazing. For those of you who are much smarter than me, they'll display a Smith chart, which I can't read. You can get a display that'll just show you SWR, it'll show gain or return loss. You can display phase magnitude. You can display a lot of things. These will do a lot more than most of us ever need. I like them because if you decide you need some of that stuff, you've got it. Your typical antenna analyzer that you buy, we'll pick on MFJ here. How many of you have seen one of these or own one? They work, don't they? What? Close enough for most stuff. Don't drop it. There's lots of things. But it's fairly easy to use in that you can just read the display. It tells you what the SWR is, or you read it on the needle. I will say these are much easier to read than the Nano VNA, especially for in-field use, because normally they got a good enough backlight. You can see them even outside at noon. A Nano VNA outside at noon, you're going to be crawling under the car to get enough shade to be able to read it. Okay, let's play with some VNAs. First thing I'm going to do is I'm going to hook one up to the computer here so we can see what you can do without looking at the screen. On the Nano, there's a software package that's called Nano VNA Saver. Had to stop and think about it for a second. That works very well. Unless you run Windows 7 and then and there's apps for lots of different systems. Come on, open up. Don't be slow. Okay, I'm not hooked up to a VNA right now. See the Smith chart? Same Smith chart. You can plug in your sweep control, start, stop, center, span, the number of segments or how many spots it's going to test. You can run it through, you can put markers on it. It has a calibration that'll help you calibrate it. A different software package actually has buttons that, like if you want to test a filter, you can click filter, tell it what band, and it'll set up your scan parameters for that band. Real easy to do. Okay, where's my serial cable? Switched over. We'll plug it in. Okay, so it's connected to it. You can see here's the return loss. Notice our return loss is pretty high. Our return loss is high because we're not hooked up to an antenna at all. We're going from 200 megahertz to 300 megahertz, so it'd be good right now if we had a 220 antenna. You want to bring your can up here and we'll...
They're tuning the antenna back here. It's busy.
Oh, well, but your can and that antenna, or do they tune in your hard hat?
No,
But
they stole my can.
oh, well, bring your antenna up here anyway. We'll do it without a...
The 220?
I don't care. Just anything right here, just so we can see it. picky people. So this is telling me, in this setup, this would not be a very good antenna on 220. Who's got a good idea why? No ground plane, no counterpoise. Any sort of a vertical type antenna either needs to be made as a dipole that's fed in the middle or have a ground plane underneath it. Now let's see what happens when we set it on this can right here. Okay, it's not sweeping. That's what it did in our last sweep. Still not much better. No, I was on the right port. It has an old calibration, but it is not currently calibrated for 220. Yeah, you don't want me singing. Okay, what do we think this is? Actually, I need to put a different chart up there if I can see it. Auto hide. Let me just. Oh. We've got it. Look at our gain. What kind of a filter is that? Passband filter. This is an adjustable passband filter that actually somebody found in one of the old Cable One buildings that he was told to get rid of, and he gave it to us to use as demonstrations. So I just changed the frequency on the dial, and we hit another sweep. Okay, who remembers what I said the dynamic range was on this particular model?
95.
About 95 dB. All of this funky stuff, that's the noise floor of the VNA. It can't measure lower than what it is, so it's just picking up noise. And that's why it scatters all over the place. And the dial says about 600. I might not have quite went up far enough. See where we're hitting the pass band of the filter? Let me change it to 700. And see, our return loss is high because we don't have an antenna, but besides that, it's not making it through our device to go anywhere. When it comes to normal filters, you're never going to get a perfectly smooth curve depending upon how they design it. You'll have little things like that. But you can see at that frequency, which we can put one of our indicators there, that's at 601 megahertz. We're getting the maximum signal through the filter. That's what I have for the primary presentation. I've got some filters up here that I'd like to see some of you guys try to check to see what they are. Who knows what band this is for?
You don't, so why would you expect them to?
Who would guess? Doesn't say.
Size of the can, I'd probably say 2 meters, 7 centimeters. Somewhere in there.
Handwritten, it says, I think 419, it's hard to read, so 70 centimeter. But come on up and you guys can play with some of this stuff. And we've got some other antenna analyzers that you can see that are easier to read. This particular one is the first one that I ever bought. Jerry back there had one at one of our antenna builds, and I liked it, so I bought one. Nice thing is you hook it up to the antenna, and then you can just spin the dial for the frequency and direct read what the SWR is. There's an MFJ right there, and what brand is the other one?
The other one's an
iPortable. So come on up and test some stuff. Some antennas there, here. If you guys want to get some hands-on playing with these, come on up. If you don't want to, sit down and relax for a while. What's neat, if any of you haven't done it, you take that tape measure Yagi that Brian just had up in the air and hook it up to one and see how much it changes just in relation of moving your hand around on the antenna. But come on, play. I'm done with the important part, or the boring part.